How are you, everybody who is watching this video? I'm very happy to have you today. And I would like to take this opportunity to welcome online students into our workshop 13, which is titled as Breadboard. Also, I would like to take this opportunity to welcome some of the physical mechatronics engineering students in this class. And my name is Olenjolai. It's the first time to meet me, in case that you've met me in some previous workshop or lectures or sessions. Maybe from fundamental stage up to the undergraduate level. These contents that we are going to share with you, or we are going to present to you, actually that can be broken down into the three parts. We are going to focus on theory, we're going to focus on simulation, we're going to focus on the hardware implementation. In previous workshop, we've been focusing about theory and simulation. But in workshop 13, this is the key workshop that is going to take us to pay attention on focusing about theory, on focusing about hardware implementation. And these contents that are very important for the beginner engineering students in the 7 fields. And also these contents are very important for intermediate engineering students, engineers, and even hobbyists. These contents are well dedicated to all the students who are pursuing ordinary diploma or undergraduate bachelor degree in electronics engineering, the students who are pursuing computer engineering, telecommunication engineering, mechatronics engineering, mechanical engineering, biomedical engineering, and electrical engineering. Let me talk quickly about what are the requirements for you to understand today's workshop. The important requirements that for you to understand today's workshop, you just need, first of all, to have a fresh mind and love the contents. And also you should have a pen, you should have a pencil, you should have a rubber, and all the drawing facilities, because engineering is all about diagrams and all about drawing. But also today, you need to have some additional parts. The first part that you might need, it's a breadboard. So this is the one of the important material. We're going to discuss about breadboards. But also, you are supposed to have some through-holes electronics components, just like this one. This is the through-holes electronics or electrolytic capacitor. But also, you need to have some also components, we call them surface mounting device. So, if that's the case and you have all of those resources, in case that you are lacking them, then you can you can access them. But today it's actual descriptions about what are we going to do and how we can use the breadboards and some electronics workbenches. In the next workshop, we'll be actually demonstrating practically about what we have been discussing. So if that's the case, you are ready for today's workshop, then let us go to the class. But before I take you to the class, let me greet all the online students and even some physical engineering students that I have in this class. How are you, students? Are you ready for workshop 13? Yes. What the title of workshop 13? Breadboard. Again, say breadboard. Breadboard. Again, say breadboard. Breadboard. Again, say breadboard. Breadboard. So let us talk a little bit about electronics workbenches. Electronics workbenches. Electronics workbenches. This is the new concept. That's why I don't do the quick review of the previous concept, because the previous workshops were focused on simulation. Say electronics workbenches. So you say that in electronics engineering field, there are two categories of electronics workbenches, namely hardware workbench, and the second one, we call it software workbench. Say hardware workbench. Hardware workbench. Again, class, say hardware workbench. Hardware workbench. Say software workbench. Software workbench. So when we've been discussing about simulations, electronic simulation software, actually we've been focusing on the software workbench. So workbench, when you call it a workbench, is actual. This is the environment that we are using to build the electronics circuits. Then we say that our main focus today is on hardware workbenches. So you say that in electronics, engineering, in electronics engineering, there are three types of hardware workbenches. Hardware workbenches. And these are namely as the first one, we call it breadboard. The second one, we call it board. The third one, we call it PCB board. These are the three types of the hardware workbenches. Okay, so in electronics engineering or in electronics engineering fields, we have three types of the hardware workbench. Before we mention this hardware workbench, we say that, for instance, in case we want to build a house, stop writing. Physical and online students, stop writing. For instance, you want to build a house. When I say stop writing, stop writing. Arafat, what are you doing? So in civil engineering, for instance, in case we want to build a house, the first thing is not to build the house. The first thing, you need the environment where that you want to build that house. And simply, in a simple language, the first thing, you need a plot of land where that you are going to build the house. Are we together? And you know that the house is actually an idea you have in your brain. And then so once you present that idea to the civil engineers or to the architect, then they can convey your idea into computerized or into diagrams by using the SolidWorks software or by using the drawing software for the civil or for the buildings. Okay? Then the next step now, that drawings will be actual, well interpreted to the constructions, or we call it structural engineer, structural civil engineer. Then later on, the structural civil engineering technicians and even artisans will actually implement the drawing on that particular piece of land. Similarly, in electronics engineering, in case you want to build a house, our houses in electronics, we call them motherboards, or we call them electronic circuits. And those electronic circuits, that we can have different types of motherboards. So in case we want to build our houses that in electronics, we call them electronic circuits, we need also a plot of land where that we can build them in hardware environment. And those plots of land, we can categorize them into these three groups. Because even if in case of I think that you know that in case of the rocks, because some of the houses are built on the rocks, we have 3 types of rocks, if you do remember, right? Or even if in case that of the soil, for instance, the soil of our country, it's not the same. Sometimes it's sandy, sometimes it's what? Pardon? Rome. So we have 3 types of soil. So even the house actually depends on the nature of the soil where the house is going to be built. Okay? Similarly, in electronics, we have these 3 hardware plots or hardware land plots, or we call them circuit plots. Are we together? Yeah, so when we learn about the hardware workbenches or software workbenches, those are the plots of land, or that is the land where we can build and implement our circuits. So if that's the case that you have understood the big picture of this concept, then I ask you to pronounce the 3 hardware workbenches that we have. The first one is called what? Breadboard. Say breadboard. Breadboard. Say with joy. Say breadboard. Breadboard. Again. Breadboard. Again. Breadboard. The second one is what? Breadboard. So remember that breadboards, it's one word. Veroboard, these are the 2 words. Veroboard. Then PCB boards, these are the 2 words. So you should not make this one to be the same word and this one. Say veroboard. Veroboard. Say veroboard. Veroboard. Say PCB board. PCB board. I don't hear ladies. Say PCB board. PCB board. I don't hear ladies. Upper lips and lower lips actually are vibrating when I want to produce a particular signal. Are we together? Yes. Are we together? Yes. Then, to verify, when it comes about the prototypes, also God made a prototype, and a very important prototypes during the creation. What type of that prototype? That prototypes we used to call it Adam and Eve. So Adam and Eve were the God's prototype, which actually have been created from the soil. Are we together? And then they have been placed in the Garden of Eden for them to be tested by God. You know what happened? God tested them, they have been passing. When the devil came, then they failed. But Adam and Eve, these are the prototypes. Once God has said that, okay, now this is the time I have to bless you and be multiplied and fill the entire earth. Then Adam and Eve responded. So by that time, God produced the final product. So Adam and Eve shifted it from the prototype and then become what? A final product. So in that final products, nowadays, we have more than 7 billion final products originating from what? The prototype called Adam and what? And Eve. In the world right now, we are more than 7 billion. 7 what? So 7 billions is just in case of engineering. We just make one prototype and test it. Once we verify, we can produce even 10 billions of the same products. And that's what we call it industrial production. Are we together? Yes. So this is the good. When you say semi-permanent, we also have semi-permanent prototypes and also we have permanent prototypes. So when you say semi-permanent prototype, it means that it just we don't want to build the circuits on the breadboards and they become a permanent. This is not for the permanent. So when you want to build it and just have a permanent circuit, in case we build it on the Vero board or we build it on the PCB board. So this is we call them permanent boards. Are we together? Yes. Are we together? Are we together? Yes. Yeah. So that's the meanings of 40 prototypes. So in case that you say, okay, I've designed a linear power supply. I've designed particular, okay, in simulations and I designed, I calculated it and simulate. I want to go for the hardware implementation. One of the requirements is breadboard. Are we together? Yes. Are we together? Yes. Are we together? Yes. Then the second definition, we define protoboards as we call it is the board for making experimental models of 40 an electronic circuit. Say experimental models. I can say experimental models. So when you say experimental models, these are the hardware models. Okay? Is it clear? Yes. Okay. The breadboard can be used to implement basic, medium, and advanced complex electronics or electrical circuits. Electrical circuits. So he said that the breadboards can be used to implement either basic electronic circuits or medium electronic circuits. Yes, and the advanced complex electronics circuits such as the one you own in your smartphone. So your smartphone has a complex or advanced complex electronic circuit. In case that you don't have a smartphone, you have a complex advanced electronics circuits within your computer. Okay, so then if that's the case, if you understood the meaning of breadboards, for instance, these breadboards, it can actually use it to make or to build or to implement a small electronic circuit where the number of components are few. What if you want to build a huge or a large electronic circuit. How are you going to achieve it? Well, that question is simple. Can I have another breadboard? So, I want to build an electronic circuit on this breadboard. But I've tried, or maybe just I began to build, and then I find the boards is not enough to implement that circuit because the circuit is huge and consists a number of electronics components. Okay, so what I was presenting to you is one challenge that you can encounter. Building or implementing the circuit Deus is busy. Building or just building the circuits on these breadboards, it has some limitation. Emmanuel, Mujuni, you are busy. One of the limitations is the size. You can build some circuits on these breadboards, but in case that the circuit consists a number of electronics components, these single breadboards will not be enough. Then the question is, how can I implement? While in this sentence we say that we can build the basic electronic circuits on breadboards, we can build the medium electronic circuits on the breadboards, we can build advanced complex electronic circuits on the breadboard. Right? So the answer of that question is simple. We can achieve that, or building advanced electronic circuits which are huge on the breadboards by joining two or more than two breadboards. How you can join? It depends. You may join these two breadboards in this in case that you want to make them long. So now this is the breadboard. You may join these breadboards actually that you say I need to increase the width. Then you find that the breadboards, it has the rails, it has a positive and negative rail. So this is the board. I can have the other ones also I can join here. I can have the other breadboards I can join on this side. I can have even some other breadboards I can join them on this side. So regardless of the size, even if they have a very huge electronic circuit, you can implement on this board. Are we together? Yes. Okay. So this is the question. How can we implement advanced, complex electronics circuits on the small breadboard? So we say that these can be achieved. This can be achieved by joining more than one breadboard. More than one breadboard. To increase either the length or the width. To increase either the length or the width. So So this is breadboard 1, breadboard 2. So this is how we can build more than one. So you can have even another breadboard. Breadboard 1, breadboard 2. So the principle used here is joining more than one breadboards. Joining more than one breadboard. That's the principle used. So from now onwards, you are no longer limited. In case you want it to be a serious mechatronics engineering student, or a serious electronics engineering student, or a serious electrical engineer, or a serious biomedical engineer, or a serious computer engineer, then one thing which I want to give you as an advice, the first thing that you must have, and you have to make sure that you work on it or you work with it, the first thing that you need, or the first practical material that you need, it's just a breadboard. And it's not expensive in our country, Tanzania. You may get a very good breadboard for only 7,000 Tanzania shillings. And for the online students, in case that you need to order it, just you can let me know in this phone number. 74 53 31. So you can have it just for 7,000. And it depends on how you keep it. But you may use it for 4 years, for 5 years, for 6 years, for 7 years onwards. Because they are, for instance, the one I have them, I've been using them for more than 4 years. So it's not something that we call it just delicate, that you have to purchase or you have to buy it frequently. No. Okay? So during my studies, for instance, myself, one of the material that I bought at early stage, I think that was the first semester of my 4 years undergraduate studies in electronics and telecommunication engineering, it's a breadboard. So I didn't want to have external force. I just bought it because I know in case that even if I want to build a simple circuit, I cannot build it on my fingers. Then why should I borrow about the breadboards of 7,000? While per day maybe I spend 8,000 or 9,000. What if just I say, okay, today I won't spend anything. Let me buy the breadboard. Then, if this is the case, which we have discussed about how we can join a number of breadboards, then now let us keep a focus on the single breadboard. So he said that a single, or before just we discuss about these single breadboards, let us discuss for a moment about electronics component. So he said that we build electronic circuits. We build electronic circuits by using different electronics components. Different electronics components. So you build the electronic circuit on breadboard. We build electronic circuits by using different electronics components. So when the circuit or when the electronic circuit is being built on breadboard. Then the electronics components are being used. So it's just like in civil engineering or in construction or in building the house in civil engineering. Stop writing. In case you want to build a house, we need different types of material. Some of this material we need first of all what? Sand, right? Then another material is what? Cement. Then another material is what? Water. Zege. How do you call zege? We need what? Concrete. Right? Then another material you need what? Water. Then another material you need what? You don't know how to build a house. The modern contemporary house. If you don't have one, for instance, the one you are living, where you have rented, it has been built by what? Stone. So sometimes you need stones. Then another building materials in civil? Bricks. Then the other one, thank you for trying, Asma. Fundi, a technician. So Asma said that you need a fundi. So is the fundi material? That is engineer Asma. The class represents 40 of the class. So you need a material called yoti fundi. What do you need again? What material do you need? Cow. Similar in electronics, in case that we want to build the electronic circuit, we need something or some of the stuff we call them electronics components. Say electronics components. Also, if you want to build an electronic circuit on the breadboards, we also need these electronics components. So this workshop is not focusing on the electronics components, but we need to have a clue or a fundamental knowledge about these electronics components before we discuss in detail about the structure of the breadboard. Right? So we say that in electronics engineering, there are two types of electronics components. Electronics components. Depending on what? Depending on the size. Depending on the size of the component. The size of electronics component. So these two types of electronics components that we have, the first one, we call it through hole. through-hole electronics component. Through-hole electronics component. And the second one is called the surface mounting device. In short, we call it SMD, electronics components. Class A through-hole electronics components. Say it again. Your neighbor has been writing. Stop writing. Class A through-hole electronic component. Say surface mounting device electronics component. So before I tell you that, which type of the components are we using on building the circuit on breadboard, I want just to show you, because we classify these two types of electronics components depending on their size. So the size, through-hole electronics components, they always have a large size compared to surface mounting device components. So through-hole electronics components are always large and have a large size, while surface mounting device electronics components, they always have a small size. Okay? But also we classify them according to the size of the terminals, or we call sometimes pins. We have through-hole pins, we have surface mounting pins. We have through-hole terminals, and also we have surface mounting terminals. So for instance, let us start with the through-hole electronics component. So I have a number of through-hole electronics components that I have, but simply, yes, because I've given you, these we call them, this one, this is a through-hole. This is the electrolytic capacitor, but we call it through-hole electrolytic capacitor. Through-hole electrolytic capacitor. Say through-hole electrolytic capacitor. So first of all, it's large in size, but also its two terminals are long. So they can penetrate in particular holes. Okay? Again, I have another example. This we call it through-hole integrated circuit. And you have them because you have a photo of them, or I gave you some of the examples. I told you to take a photo in all sides. So this we call it through-hole integrated circuit. Say through-hole integrated circuit. So this we call them pins. While this one we call them terminals, this we call them pins. The number, this a lot of them. Because this is actual, it's a logic gate. Logic gate integrated circuit. So this what we call through-hole integrated circuit. It has actual the pins where that these pins can penetrate or can enter into the particular holes. Are we together? Are you together? So you have a number of examples I shared with you. Take a photo of them, go through those photos and think about them. When we talk about surface mounting, electronics components are just like this one. This is an IC. It's just like this one, this IC. But you find that this is through-hole, but you find it is very small. These are the surface mounting component. This is a through-holes, this is the through-holes, this is through-hole. But here we have a number of 40. This is the light emitting diode. Light emitting diode, these are the resistors. But we call them surface mounting resistors. They are very small. Do you see? Eh? No, you haven't seen. You? Those are the electronics components. All of those stuff that you see them, they are surface mounting. So these are the surface mounting component. You see? There you see that surface mounting resistor, surface mounting diode, surface mounting capacitor. Okay? So these are the surface mounting components. For instance, this IC, it's a surface mounting IC, while this is through-hole. You see, this is huge, this is small. Okay? Eh? No. Why no? Listen. This is through hole. Okay, I will show you for those who are being physically here. With these through holes, on top of this we call it photodiode. It's electronic diodes, or we call it a special purpose diode. And then beside it, or at the bottoms of this through photodiode, there is 4 surface mounting discrete components, which are resistors. And then this is the potentiometer, and this is the integrated circuit. But below it, we have 2 surface mounting light emitting diodes, and also you have 2 surface mounting resistors. Are we together? So what you can note, for instance, this is the through hole surface mounting IC. While this is surface mounting, this is surface mounting device integrated circuit. While this is through holes integrated circuit. So you see it is pins, and its size, this is large, this is small. Similar for the electric capacitor, this is the through holes electric capacitor. While the surface mounting, they have a very small size. So you have to be familiar with the size, or with these 2 types of electronics components, because you'll need to use them on building your house. Okay, so if in electronics we have through holes electronics components, and also you have surface mounting electronics component, then the question we have, which components are we using on building electronic circuits on the breadboard? That's the question that we have. Which electronics components are we using on building electronic circuit on breadboard? Ask your neighbor. Do you think that which electronics components are we using to build the electronic circuits on breadboard? I said ask your neighbor, physical students and online students. Are we using either through-hole electronics components on breadboard, or are we using through-hole surface mounted device electronics components on breadboard, or are we using both through-hole electronics and the surface mounting device electronics components? So ask your neighbor, and once your neighbor gave you the response, then give him or just ask him or her another question, the second question. Why? Why are we using what you have said? I say it is time for you to talk with your neighbor. We have just 3 choices. Either through-hole electronics components, or surface mounting device electronics components, or both SMD and through-hole. And why? So that's the question I asked you to ask your neighbor. Which electronics components are we using on building electronic circuits on breadboard? So the response is this one. We use only through-hole. Through-hole electronics components to build the electronics circuit on breadboard due to their size, due to their large size of terminals or pins. So we use through-holes electronics components because they have large size or large terminals or larger terminals or pins compared to surface mounting device. So when you say a through-holes electronics component, example can have electrolytic capacitor, so this is positive, this is negative, and then here we have 470 microfarad, voltage rating 63 volt. So this is through-hole electrolytic capacitor. So we are using this because, for instance, this is the breadboard. We are using through-holes electronics components, and the breadboards have a number of holes. They have a number of holes. So we need these through-holes electronics components in order to place them or to fix them on these holes. That's why we need them. So the surface mounting device, remember that they have a shorter and a small terminals and pins. You cannot actually place them into the breadboard. Right? That's the simple reason. Is it clear? In case you have a question, you may ask. So that's the brief descriptions about electronics components. Then let us focus on the breadboard once we know about the workbench. A single breadboard has three main parts. The first part is called the power rail. The second part, class A, power rails. Say power rails. The second part is called the circuit area. The third part is called the integrated circuit or IC base. Class A, power rails. Again, say power rails. Class A, circuit area. Circuit area. Circuit area. Circuit area. Say integrated circuit IC or IC base. Integrated circuit base. Again, integrated circuit base. Or simply call it IC base. Say IC base. Say IC base. So again, we say that the breadboard allows both internal and a external connection of different parts of the circuit. So the breadboards allow both internal and external connection of 40 of different parts of 40 of the electronic circuit. Different parts of electronic circuit. So you can actually connect different parts or different electronics components either externally or internally on the breadboard. Some of the holes of the breadboard are internally connected. In particular pattern. So some of the holes, because a breadboard consists of a number of holes, some of the holes of the breadboards are internally connected. Not in all or all of them, but in particular pattern. In particular patterns. So for you, for a proper use of the breadboard, you have to know, or you have to learn, the built-in connection of some rails of breadboard. So for the proper use, in case that you want to use a breadboard to implement a particular schematic circuit diagram of a particular electronic system that solves a particular problem, then you as electronics or as the lover of electronics engineering, you have to learn the built-in connection. Why should you learn? In order to avoid an accident of connecting or of having wrong connection within the breadboard. Because the breadboards, this internal connection is not done by the user, but the internal connections of some of the holes is actually made by the manufacturer of the breadboard. So once you buy the breadboards the way it is, It has the internal connection. Just like this one, these breadboards, they have internal connections built in. We call it built-in internal connection. Say built-in internal connection. So some of the holes, you can find that they have been connected in the particular pattern within, internally. And then for you, once you are building your circuits on the breadboards, you are allowed also to use jumpers to do the external connection. So we are always using special wires. We call them jumpers. Say jumpers. Say jumpers. So we do the external connections of different parts or different electronics components on the breadboards by using special wires that we call them jumpers. Say jumpers. So these are the jumpers. So you buy them. In particular, they have different size. Some of the jumpers are longer. Some of the jumpers are short. And in electronics, we have 3 types of jumpers. We have the first type, or just I mentioned, it doesn't mean that the first one is the first type. But one of the types of the jumper, we call it male to male. Say male to male. Say male to male. Say male to male jumper. So this is the male to male jumper. So it means that in case of the breadboards, you can fix, you can actually use this male connection or male jumper to take a signal from one point to another point. Okay? And most often we use male to male jumpers in just doing the external connections on the breadboard. The second type of jumper is called the female to female jumper. Say female to female jumper. Female to female jumper. So this is female to female jumper. It's completely different from male to male jumper. So the female to female jumper, it has a hole in 2 sides. While the male to male jumper, it has external connector, just like this one, in 2 sides. Okay? Then the third type is actually the combination of male. When we talk about male and female in electronics, you should ignore about male and female in biological part or in the human part. When you talk about male and female, because for instance, the USB cable and the USB port that you have, the USB cable that you have, it's male. Those connectors are male. And then the USB, actually called as the USB ports, in your either computer or your mobile phones, those are the female connectors. We call female USB port, male USB port. So the third one is called the male to female jumper. Male to female jumper. So this is male side, this one, male side, and this the female side. So we mostly use male to male jumpers in external connection of the breadboard. Right? Right? Sometimes, in case we have the sensor we had, which is the flame sensor. Can I have it? Flame sensor. In case that we need to do the external connection, or we want to connect him, the flame sensor, and then the flame sensor, it has actually the male pins. Then I can use the female to female connector, and then because I want this sensor to be in particular distance. Hello, Ade? So for instance, I want this sensor to be located here, but it's far from from the breadboard. Then I can use male to female connector, male to female connector to connect this sensor to the breadboard. So in some cases, we may use the male to female connector, but we don't expect to use female to female connector on the breadboard. We use female to female connector, especially in PCB board. Are we together? Why? Because the breadboards need the male. If it's electronics components, it should be male, because all the parts, the top parts of the breadboard, all parts of the breadboards, these holes, we call in electronics, these are the female. All the holes in the breadboard, we call them female. So this one, in order to allow the connection, it just need either a male jumper or a female, a male jumper or a male through-hole electronics component. Right? Is it clear? Okay. Okay, so now let us stop writing and stop actual data. Pay attention here. I'm going to draw the part of this breadboard. I'm not going to draw all the parts of the breadboard. I'm going to draw just a small part of it. But for you, because you have a breadboard, you can draw a breadboard, just a single breadboard, with all the holes. For me, just for the demonstration purpose, because I want to teach you about internal connection. Internal connection. Let us learn this internal connection, because this one we have to learn in class. Internal connection. Internal connection of breadboard. Breadboard. Say internal connection of breadboard. Again, class, say internal connection of breadboard. This is according to the manufacturers of breadboard. There are different companies that are manufacturing breadboards. So this is my physical layout of the breadboard. Then I have the third mentioned part, which is IC board. Then I have this part. Then I have this part. So in this layout, stop writing, I said. This is figure 2. Listen careful, because this is the prerequisite of practical hardware implementation. 3 main parts of breadboard. So listen, I said stop writing. This part, if actual that you align the breadboards in this style, do you see? Eh? This style. Then we say that this first part, this one, we call it power rail. And also this one, or this part, we also call it power rail. Say power rail. Power rail. Power rail. That's what we mentioned here. So in the breadboard, in the single breadboard, we have 2 power rail. We have 2 power rail. We have 2 power rail. Then we say the second part is called what? Circuit area. Say circuit area. So let me label it. This one, so we have 2 parts where we call it circuit area. So this you call it circuit area. Say circuit area. Then this part we also call it circuit area. Say circuit area. Say circuit area. Then the third part we call it integrated circuit, so IC base. So the middle part, we call it IC base. Say IC base. Say IC base. So now it's a time for you to take a breadboard and then analyze or show your neighbor, this is what you call the power rail, and this is what you call the circuit area, and this is what you call the IC base, and this is what you call the circuit area number 2, and this is called the powering. So it's a time for now for the exercise to identify those parts before I teach you the internal connection. So simply this one, we can call it three main parts. 3 main parts of what? Of breadboard. So show your neighbor now. This is circuit area, this is power rail, and this is IC base. Quickly. Do that. Okay. So this is this is figure 3. We have the internal connections of the breadboard. That's what you want to study. Stop writing, listen, and watch. Remember that this part, and this part is what we call the power rail. I will just write it in abbreviation. Power rail number 1. This part and this part, also these two parts, this part and this part is what we call them power rail number 2. I said stop writing, stop drawing, listen and watch. Then this part is what we call the circuit area. In short, it means that circuit area number 1. And this one is called the circuit area number 2. So listen. We call it rails because you can find that in power rails, we have a number of holes. But the difference, I said stop writing and listen and watch. The difference between the power rail and circuit area. The holes in power rails are arranged in patterns of 5. 5 hole, 5 hole, 5 hole, 5 hole, 5 hole. First of all, how many holes does the breadboard set you have? How many holes are there? Count the holes. Count all the holes within the breadboard, like this one. How many holes do you have? 840. So this we call it 840 holes breadboard. Okay? Are we together? So this is power rail number 1, power rail number 2. What the main function of power rail? Before I explain about it, the internal connection. The main function of power rails means that this is a rail where that we supply power from the external source of power. Remember that when I've been teaching about linear power supply, in the block of the load, we had the positive connector and negative connector, where we call them power bank. Do you remember them? Do you remember them? So for the breadboards, it's actual, we need to supply power into 2 holes. For these guys, and also for this part, we just need to supply power into 2 holes. All the remaining holes will be supplying power, but the external power is connected to these 2 holes. But because the internal, the holes, the power rails, the power holes, or the holes in the power rails, they have internal connection, so you can have a power bank. The other holes will be remaining, or will be acting as a power bank. Are we together? Are we together? So simply, the power rail is the main function of power rail to connect your circuit that will be building in circuit area with external supply of power. But also these power rails actually will be acting as a power bank to your circuit. Maybe you need power in different parts of your circuit. Then you can draw power from the power bank where it is power rail. Are we together? Are we together? Are we together? Are we together? This is power rail. So this one is power rails and this one is power rail. Then we have another the second part, circuit area, where we have circuit area A and circuit area B, or circuit area 1 and circuit area B, circuit area 2. So in the circuit area, this is the part on the breadboard where that we electronics engineers, we have to build our circuit on the circuit area. So circuit area, this is the part of the breadboard where the circuit is being built or is being implemented. Are we together? That's the main function of circuit area. Say circuit area. So in case that you have your 4 diodes, you want to implement a full wave rectifier, you will locate them in this circuit area. In case that you have your electrolytic capacitor, you want just to implement the filter, then you have to place them in this circuit area. Maybe you have your voltage regulator, and then you want to fix it. You have to fix it in the holes of the circuit area. Are we together? Then we have the third part. What the main function of the IC base? IC base, the main function of IC base, because the IC base, this is the middle rail. This middle rails, this is what we call the IC base, right? So you can find that there is the actual that this part, it is measured some centimeters or some millimeters within the breadboard. So the main function of this IC base is actual to hold the through-hole integrated circuits on it and avoiding a short. If, for instance, you have a through-holes integrated circuit and then you place in the circuit area, actually you are going to short all the pins of this or a number of pins of this IC base. Why? Because they'll be interconnected internally. So where the proper place that we have to connect it, the through-hole integrated circuit? Well, the proper place we have to always to connect it or to use the IC base in order to accommodate. So this one is accommodating what? Integrated circuit. Say integrated circuit. So the IC, so for instance, you see this is the proper place. So this is the main function of IC base. So IC base is actually to accommodate integrated circuit. In case that in your circuit you need to use through holes integrated circuit. So this is the proper place where we have to locate our through holes integrated circuit. Any other place, maybe circuit area or power rails, actually you are going to damage that integrated circuit as long as you turn on the power. Those are the safety and precaution. Okay? Okay? Are we together? So this is the function of 40 IC base. All the integrated circuits, whether of the 4 pins or maybe 100 pins, should always be located in the first rail of circuit area and second rail of circuit area B. And that IC base, it has actual to rest on this IC base. I have explained the function of each part. Are we together? Yes. Is it clear? Yes. Is it clear? Yes. If it is clear, when also I will repeat this, the function of each part. Once I have told you, I have shown you the internal connection of the holes within the breadboard. Separating, pay attention. For the power rail, all of these or most of these holes are connected horizontal. So these are the holes which have internal connection. So within the breadboards, these holes are internally connected. And when we have a continuity check device or a continuity tester, then we'll start or we'll realize what I'm teaching you about the internal connection like that. Then, that is, so it depends. Some of the breadboards, some of the breadboards you find that, how many holes do we have in power rail? How many holes? Pardon? 100 holes. So in the first rail, we have 50 holes. In the second rail, we have 50 holes. Some of the breadboards, you'll find that 25 holes of the left-hand side in the one power rails are internally connected. And 25 rails on the other sides on the same rail, power rails, are internally connected. So in case that you want to interconnect them, so you just need a male jumper, one male jumper, and then you draw power from here and this one. So once we do, for instance, in some of the breadboards, you find that there is a disconnection in between. It means at the middle of the power rail. Okay? So for that case, you have to check always. Hello? Hello? For that case, you need an external to connect them externally. But for most of them, we have the internal connection of all the 50 holes. Then, for this case, this is another power rail. We have also internal connection from one hole to another hole. 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 Again, similarly for this case, this is horizontal internal connection. 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 Horizontal internal connection like that. Similarly, here we have horizontal internal connection. 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 Horizontal internal connection like that. So it means that in case of the power holes, in the case of power rails, the holes are internally interconnected, all the 50 holes. For some of them, 25 are internally connected, other 25 are internally connected. So you have to check before you use the breadboard. Because sometimes you might think that the circuit is not working. But unfortunately, you don't know the internal patterns or the internal connections of the breadboard. Are we together? Yes. Are we together, class? Yes. Well, so that's why we say that if this is the powering, in case I want to supply power, I have my linear power supply, or maybe I have an adapter, or maybe I want you to connect the two wires from the step-down transformer. What should I do? Simply, I just need to take the live wire and connect it to here, and then send this one. So this is live wire, this will be actual neutral wire. If you have DC source, maybe I want to connect the battery, I will have a positive at this point, I will have a negative. So once I connected the external source to these two holes, then all of these holes will have a positive power. All of these holes will have a negative power. Are we together? In case I want to distribute more power, and I want to extend the circuit, the power rail, I just need two male jumpers to connect the first hole of this power rail with the first hole of this power rail. So I will just need the male jumper to connect them. Remember that I have supplied. So this one has been used. So I just need the second hole. Just I will connect the jumper in the second hole and the first hole of this power rail. For that case, hello. For that case, for this part, all of these holes I have positive power. And as all of these parts I have positive power. So these are 49, 48 will remain, 48 holes. And here we have 49 holes. Total makes 97 holes. So you can supply or you can draw power from any of those 97 holes and supply to your circuit area or the different electronic parts that needs the power for them to work. Are we together? Are we together? So these two power rails, they will be acting as power bank. Then, in case I want you to connect, just I want to draw power from this negative. So I just need another male jumper and connect it to here. For that case, I will have 48 holes which have the supply, or they can supply the negative power supply. And here we'll have 49 holes. Because in some of the breadboards, this one is labeled as positive and this one is labeled as negative. This one is labeled as positive, this one is labeled as negative. What does it mean? This is actually to remind you that here we have positive power supply, here we can have negative power supply. In case there is no sign, for instance for this breadboard, which does not have sign of of either positive or negative, you are the one who is responsible to choose. You are responsible to choose. You are responsible to say that this is positive, this is negative. Are we together? But you have to remember always, because in case that you interconnect positive power supply or positive power and negative power, you are going actually to cause an electronic or electric accidents. You are going to damage all the electronics components, and actually you can burn that plastic material of the breadboard. So safety in electronics is very important. Are we together? Is it clear, class? Yes. Eh? So remember that the first power rail is not interconnected or internally connected with the second power rail. The first power rail is not internally connected with the second power rail. In case you want to connect them, you have to use external connection by using the male-to-male jumper. Are we together? Are we together? Are we together? Yes. Well, let us now discuss about the circuit area. For the circuit area, the internal connections is actual vertically. Say vertically. So we have 5 holes. So this hole is internally connected with this one. This hole is internally connected with this one. But there's no, remember, in the case of power rails, in the case of power rails, there's no internal connection between this hole and this one. Or either holes of this side and this side. Similarly for this case. Okay? Okay? Take that precaution. Then this is internal connection. Then this is internal connection. 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 Etc. etc. For the circuit area number 2, similarly, the internal connection of the holes is, or the internal connection is made vertically. Internal connection. Internal connection. Internal connection. Internal connection. Internal connection. Vertical internal connection, etc., etc. for all the holes. Remember that there is no any internal connection between this hole. There's no internal connection between this hole and this hole. No internal connection between this hole and this hole. The internal connection is what? Vertical. Okay? Okay? Are we together? Then let us discuss. So that's why that you have to be careful whenever you are building a circuit on the breadboard. Because otherwise you can be good in just doing simulations or doing maybe drawing the circuits on the paper, but when it's come for the hardware implementation, you may cause an accident. Listen, again, there is no internal connection between the circuit area number 1 and circuit area number 2. So for these guys, no internal connection. This is IC. This is what we call IC base. There is no internal connection between circuit area number 1 and circuit area number 2. Number 2. Okay? Okay? So it means here we have insulator materials. There is no internal connection between the first circuit area circuit area rail and second circuit area rail. Why? Because here we have insulator. Here we have insulator. Here we have insulator. Here we have insulator, etc., 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 etc. Are we together? Are we together? Yeah. So you may draw the entire breadboard and make sure that, because in the next workshop, we are going to prove what I have taught you theoretically to realize whether the internal connection, the actual internal connection of what of the breadboard, or it's not the actual internal connection of the breadboard. Are we together? Okay. So remember, the main function of power rail is what? Is to supply, first of all, to receive power from external source. Second, to supply power to different parts of the circuit. Okay? The main function of the circuit area is actually to accommodate your circuit, or to accommodate electronics components according to your design, or according to the circuit that you want to implement. The main function of IC base is actually to accommodate through-hole integrated circuits. If there's any question, you may ask. Okay, so you didn't understand how you connect power rail number 1 and power rail number 2? The second hole, because the first hole it has already been used to supply power from the external source. Whether the battery, mostly battery, or adapter, mostly. So that's why the first holes have been used to provide positive and negative power to this power rail. So in case that you want to connect it, you have to use the second hole. The second hole for these power rails and this one to connect them in the first, because for this case, there's no any external power supplied on it. You may connect the external power supply on this side or on this side. It's not compulsory for it to be connected. So you're allowed, either you can connect the external source here, and then you do the external connections of the power, you supply power to this power rail, or you connect the external source to the two holes of this power rail, and then use the jumpers to distribute power into the second power rail. So Mavumba's questions actually was asking about why should you use the second hole of the power rail. So I've explained that the first holes have been used to connect the power from the external source to the breadboard. Another question? Okay. In case that you don't want to use the first power rail. Angoja nitakujibu. Another question? No? Eh? Okay, so let's say that this is the end of workshop 13 about breadboard. I ask you to go through it, review it, before we go for the next workshop, workshop 14, where actually will be, I believe that will be a more practical workshop. And we'll be starting on, first of all, analyzing or realizing the internal connection of the breadboards, and then we are going to connect some circuit and do some measurements. So thank you very much. I welcome you in the next workshop. Be blessed. See you in the next workshop. Did you understand? Okay, so I know that today, this workshop has been a little bit challenging, but you made it. Tell your neighbor you made it. Okay, so now let us congratulate you and your neighbor. 1, 2, 3. Hongera. Imara. Wow, thank you. See you in the next workshop. Mungu ibariki Afrika, wabariki